Hello everyone. Today again I'm here with another topic of class 10 mathematics where I'll be discussing about introduction to trigonometry. Now in this chapter what we are going to learn is first we'll talk about the definition of trigonometry. Then we'll be talking about what are the basic trigonometric ratios, following which we'll discuss about trigonometric ratios of some specific angles, and then we'll talk about trigonometric identities. So let's start with the discussion of the chapter. So moving first with the definition of trigonometry. What is trigonometry? It is the study of the relationship between sides and angles of a triangle. Now this trigonometric ratio can be applied to any kind of triangle, but we will restrict ourselves the trigonometric ratio of right angle triangle. So that means we'll be only talking about trigonometric ratios of right angle triangle, not any other triangle. Going forward in this one, if you talk about the basic meaning of trigonometry, that how we can understand it, then here if you break it trigonometry into three parts, we'll have tri, gon and metron, where tri means three, gon means sides, and metron means measure. So this is three sides measure what is about we are going to discuss. Now let's start with the first subtopic of it, where we'll be discussing trigonometric ratios. So when it comes to trigonometric ratios, as we are saying that we are going to discuss about right angle triangle. So one angle will be 90 degree. And then the other two angles will be acute angles. And we'll be talking about trigonometric ratios with respect to these acute angles. Now since there are two acute angles, it is very important for us to understand that with respect to which angle we are trying to find trigonometric ratio. Like in this case, if I will take in triangle ABC, if I am trying to find trigonometric ratios with respect to angle A, then for angle A, here the side BC will be the opposite side, AB will be the adjacent side, and AC is the hypotenuse. In hypotenuse case, there should be no confusion, as we already know that in a right angle triangle, the side opposite to right angle is hypotenuse. Whereas when you talk about angle C, then in that case, here the BC will be the adjacent, AB will be the opposite side, and AC will be the hypotenuse. So it is very important for us to understand that what is opposite, adjacent and hypotenuse in order to find trigonometric ratio. Now let's move to the next section, where we'll be talking about how many trigonometric ratios are there and how we can find them. So here we'll be learning about 6 trigonometric ratios, which will be sine, cos, tan, sec, cosec and cot. These are the 6 trigonometric ratios about which we'll be learning with respect to an angle. Now here, why 6 trigonometric ratios? As we have a triangle which is having 3 sides, and so there are 6 possible ratios are. And each of the ratio is given a name with the trigonometric ratio out of sine, cos, tan, cot, sec, cosec and cot. So here, what is sine of an angle? So remember, these formulae is going to be fixed throughout only based on what type of triangle you have, and with respect to what angle you are talking about, your opposite, adjacent and hypotenuse will change. Formula of these trigonometric ratio will remain same. So if you talk about sine of an angle A, in that case it will be denoted as sine A, and it is written as opposite upon hypotenuse. When you talk about cosine of an angle A, that can be written as cos A, and it is adjacent upon hypotenuse. If you talk about tangent of an angle A, that is written as tan A, and it is opposite upon adjacent. Then we have cotangent of an angle A, which is written as cot A, and it is adjacent upon opposite. Then we have secant of an angle A, which is written as sec A, and it is hypotenuse upon adjacent. Next we have cosecant of an angle A, which is written as cosec A, and it is hypotenuse upon opposite. So these are the 6 trigonometric ratios and its corresponding formula, which we'll be using to find trigonometric ratios. Now one thing, if you observe here, in this case, what we find here is, if we compare the formula of sine and cosec, we observe is that their ratios are just reciprocal of each other. When we talk about cos and sec, again we observe that their ratios are reciprocal of each other. And if we compare tan and cot, we find the same thing, that the ratio are reciprocal of each other. So that means we'll have a relationship between sine and cosec, we'll have a relationship between cos and sec, and we'll also have a relationship between tan and cot. And that relation we'll be learning it as reciprocal relation. And as we have already seen that sine and cosec is having reciprocal relation, what we can write is that sine of an angle A is equals to 1 upon cosec of an angle A, which can be written as sine A into cosec A, which is equals to 1. Similarly, we have also seen that cos and sec are reciprocal of one another, so we can write cos equals to 1 upon sec of an angle A, which will be cos A into sec A, which is equals to 1. And the third, which we have seen between tan and cot, so if you take tan A, we can write it as 1 upon cot A, and if you cross multiply, we can write it as tan A into cot A equals to 1. So these are the 3 relations which is known as reciprocal relation. If I will talk about quotient relation, so in that case what we can say, in the quotient relation, the first thing what we observe here is, if I will take sine A upon cos A, we will get opposite upon hypotenuse upon adjacent upon hypotenuse. When you do cancel it, you will get opposite upon adjacent, which can be written as tan of angle A. So that means, what is that? Tan A, we can write it as sine A upon cos A, or sine A upon cos A, we can write it as tan A as per our requirement. The another one is cos A upon sine A, which will be adjacent upon opposite. We know that it is a reciprocal of tan, that can be written as cot A. And this is what the quotient relation is. Moving to the next part, as we are saying that the trigonometric ratios are angle dependent, what happens if we take a similar triangle and we try to find out the trigonometric ratios of it? So remember, the value of trigonometric ratio will not change as long as the angle remains the same. That means if you are not changing the angle, the trigonometric ratios value will not change irrespective of the size of right angle triangle. As in this case, if you see here, if I will take triangle A, B, C, this is P, Q, and this is X, Y. What we observe here is the triangle ABC is similar to triangle APQ is similar to triangle AXY. And if you talk with respect to angle A here, we can write sine of an angle A as BC upon AC. We can also write it as PQ upon AQ. We can also write it as xy upon ay. And in all these cases, what we'll find is that ratio will not be different. As we know, a ratio can have many equivalent form. So once you simplify all these ratio, it will end up giving you the same answer. And the similar way you can even find out for cos of an angle, sec of an angle, tan of an angle, cosec of an angle, and cot of an angle. I have just given here sin A as an example. Same information, same rule applies to other trigonometric ratios also. That means what we can understand from here is that if I have sine of angle A equals to suppose sine of angle B, I can write it as A equals to B. If I have cos of an angle A equals to cos of an angle B, we can write it as A equals to B. If we have tan of angle A equals to tan of angle B, we can write A equals to B. And further we can continue the same for sec, cosec and cot. Also, we need to understand that if suppose it is given that x equals to y, those are two angles, then we can say that sine x will be equal to sine y. I can also write it as, if x equal to y, I can write it as cos x equals to cos y. I can also write it as tan x equals to tan y, and the same thing again will apply to other trigonometric ratios like cot, sec and cosec. Moving to the first question, here it is given that in triangle ABC, right angled at B, and AB is 24 centimeter, BC is 7 centimeter. We have to find the value of sine A, cos A, sine C and cos C. So in order to find the value of these trigonometric ratio, we'll draw the triangle. It's A, B, C. It is given that AB is 24 centimeter, BC is 7 centimeter. And in order to find that sine A, we know that we'll have to use hypotenuse. So let's find out the value of AC first. So what we can say by Pythagoras theorem, AC square will be equals to AB square plus BC square, which will be 24 square plus 7 square. We can write it as 576 plus 49, which will be equals to 625. That is the value of AC square, which implies AC will be equals to square root of 625, and we can write it as 25 centimeter. Once we have found the value of AC, now we'll find the value of the different trigonometric ratio. So here sine A, we are talking with respect to angle A. So in that case, what will be that opposite, it will be BC upon hypotenuse, it is AC, and the value will be 7 upon 25. For cos A value, we'll get adjacent by hypotenuse, which will be AB upon AC, and the value will be 24 upon 25. Next, if you want to find out the value of sine C, now since we are talking with respect to angle C, then the opposite will be 24 centimeter, which will be AB, and adjacent will be 7 centimeter, that is BC. So sine C will be opposite, which is AB upon hypotenuse AC, whose value will be equals to 24 upon 25, and then the value of cos C, that will be adjacent BC upon hypotenuse AC, and so it will be 7 upon 25, which will be the value of these trigonometric ratio. The next question is that it is given that 15 times cot A equals to 8, we have to find the other trigonometric ratios. So it is given that 15 cot A equals to 8. That means cot A will be equals to 8 upon 15. And we know that cot A is what? It is adjacent upon opposite. So here we'll take let adjacent, which is AB here. So AB equals to 8K, and opposite, which is BC, equals to 15K. Now in order to find the other trigonometric ratio, we'll have to find out the value of AC. So again we'll use Pythagoras theorem, and we know that AC square equals to AB square plus BC square, which will be 8K whole square plus 15K whole square, which will be 64K square plus 225K square, which we can write it as 289K square. This is the value of AC square. So the value of AC will be square root of 289K square, which is 17K. And once we have found the value of AC, we can find the other trigonometric ratio. Now, therefore, the value of sine A, that will be opposite BC upon hypotenuse AC, and we can write it as 15K upon 17K. The value will be 15 upon 17. Cos A will be equals to adjacent upon hypotenuse, and so that will be equals to 8K upon 17K, that is 8 upon 17. Next, if you'll find tan A, that we can directly find using the reciprocal relation, or we can find here, which will be tan is opposite, which is BC upon adjacent AB, and that will be 15K upon 8K, which is 15 upon 8. And now you can find out the value of sec A, which is just the reciprocal of cos A, which is AC upon AB, and the value of it will be 17 upon 8. And finally, the value of cosec A, which is the reciprocal of sine A, which will be AC upon BC, and so we can write it as 17 upon 15. And this is how we can find out the value of other trigonometric ratios. The next question is, in triangle PQR, right angled at Q, it is given that PR plus QR is equal to 25 cm and PQ is 5 cm. We have to determine the values of sin P, cos P and tan P. Again, before we start, let's draw the triangle PQR. Now here they have given that PQ is 5 cm, and in this case also it is given that PR plus QR is 25 cm. If you take let PR equals to X, then that means the value of QR will be 25 minus X. Now we'll use Pythagoras theorem again. So we know that PR square equals to PQ square plus QR square, where PR is X, so it will be X square plus PQ is given as 5, and QR will be 25 minus X. When we solve it, we'll get X square equals to 25 plus, expanded using A minus B whole square, we'll get 25 square plus X square minus 2AB, which will give 50X. Now here we can cancel X square and X square. We will get here 50X when it is transposed to the left. We'll get 25 plus 625. That means 50X will be equals to 650, and so the value of X will become 13. And once we have got the value of X, therefore we can say that PR equals to 13 centimeter and QR will be equals to 12 centimeter. So we are ready to find the value of sin P, cos P and tan P. Let's find it out. So therefore, the value of sin P, we are talking with respect to angle P. So opposite is QR and hypotenuse is PR. The value of sin P will be 12 upon 13. Then cos P, the value of cos P, which will be adjacent, which will be PQ upon PR, which will be 5 upon 13. And then finally we can find out the value of tan P. So the value of tan P, it will be opposite, which is QR upon PQ, and that will be equals to 12 upon 5. Moving to the next question now. In this question, it is given that if angle B and Q are acute angles such that sin B equals to sin Q, then prove that angle B equals to angle Q. In order to prove it, we are going to draw two triangles A, B, C, P, Q, R. Now it is given that sin B equals to sin Q. Sin B will be opposite AC upon hypotenuse AB, which will be equals to sin Q is PR upon PQ, which we can write it as AC upon PR equals to AB upon PQ. Let it be K, which implies we can write AC equals to KPR and AB equals to KPQ. Now if we use the Pythagoras theorem in triangle ABC, then the value of BC will be equals to square root of AB square minus AC square, which will be equals to KPQ whole square minus KPR whole square, which can be written as K square into PQ square minus PR square. Further, we can write it as K into square root of PQ square minus PR square, which will be equals to K into, by Pythagoras theorem, square root of PQ square minus PR square, we can write it as QR. And so that means we will get BC upon QR equals to K. So here what we observe is that AC upon PR equals to AB upon PQ, which is equals to BC upon QR. Therefore, triangle ACB will be similar to triangle PRQ by SSS criteria, and so we can say that therefore angle B equals to angle Q. Let's move to the next question. Here what is given that in triangle ABC, right angle at B, if tan A equals to 1 upon root 3, find the value of first sin A into cos C plus cos A into sin C, and the second one cos A into cos C minus sin A into sin C. It is given that tan of angle A equals to 1 upon root 3. And we know the value of tan is opposite, which will be BC upon adjacent AB. Now, if we'll take let BC equals to K and AB equals to root 3K, then by Pythagoras theorem, we can find out the value of AC. So AC square will be equals to AB square plus BC square, which we can write it as root 3K whole square plus K square. On solving, we'll get the value of AC as square root of 3K square plus K square, which is equals to root 4K square, and that is 2k. Now, first we'll list down the values of these trigonometric ratios. So, sine of angle A, which is opposite upon hypotenuse. Here the value of AB is root 3k, BC is k, and AB is 2k. Substituting the value here, we'll get that k upon 2k, which will be 1 by 2. Then cos of angle A, that will be equals to adjacent, which is AB upon hypotenuse AC, will get root 3k upon 2k, which will be root 3 upon 2. Then sin C, the value of sin C will be opposite AB upon hypotenuse AC, that will be root 3k upon 2k, which is root 3 upon 2. And the value of cos C, that will be adjacent BC upon hypotenuse AC, that will be k upon 2k, and that will give 1 by 2. Now we'll find out the first and second question. So first one is, we have to find sin A into cos C plus cos A into sin C. So when you substitute the values, sin A is 1 by 2 into cos C, that is also 1 by 2, plus cos A, which is root 3 by 2, into, we have sin C, that is also root 3 by 2. On solving, we'll get it as 1 by 4 plus 3 by 4, which will be 4 by 4, and that is 1. Next question is, we have to find out the value of cos A into cos C minus sin A into sin C. So second question, that is cos A into cos C minus sin A into sin C. Now cos A, the value of it is root 3 upon 2, and cos C, it is 1 by 2 minus the value of sin A is 1 by 2, and sin C is root 3 by 2. Since both the values are equal, it is root 3 by 4 minus root 3 by 4, it will be equals to 0.